As we said, ethers are good solvents, and they're good solvents because they're generally unreactive, right? And of course, we never deal with absolutes in this class, so anytime we say something's reactive, we just mean that they're generally unreactive. The exception here is strong acids. And really, it's very strong acids. Not every strong acid is going to do this, but some very strong acids that also contain a nucleophilic component to them. So for example, if you added HBr, some water, and some heat, you wouldn't want to use ether as a solvent because then it would split your ether apart. In this case, it would split it into phenol and ethyl bromide. Let's go take a look at this with a different molecule. So here we've got tert-butyl ethyl ether, and then we'll use HI as the acid instead, just to mix it up a little bit. First part is going to be the proton transfer, protonate your ether. And now that it's got this positive charge, we've got a pretty good leaving group. And then we've got iodine, which is a pretty good nucleophile. And so it can do a backside attack, an SN2 reaction, because this component is primary. And then that would split it up into tert-butanol. And then this ethyl iodide. This could go even further if you have an excess of HI. Right, we could have this tert-butanol do another proton transfer type mechanism to form water here. Of course, then you've got a good leaving group on a tertiary alcohol. The leaving group is going to go ahead and leave, form a carbocation, and then this I- can come in and attack that carbocation to do the substitution, right? So in this case, you could get both of these components being substituted. Right, again, this is tertiary, so it's going to do an SN1 type of reaction. In this case up here, this is not actually going to do that even if you have an excess of HBr, and that's because you have this this SN2 carbon, right? So there's no SN2. And it's not a good leaving group either. You're not going to have that positive benzene either.